On Saturn's largest moon, Titan, liquid gasoline falls from thick orange clouds and drifts down so slowly, a person standing underneath would barely feel it land. The moon's gravity is only 14% of Earth's, and its atmosphere is nearly twice as dense, so raindrops the size of marbles can take almost an hour to reach the ground. It isn't water falling from those clouds. It's liquid methane and ethane, chemically close cousins of the gasoline in a car's fuel tank, raining onto a world colder than 290 degrees below 0 Fahrenheit. Titan is bigger than the planet Mercury, wrapped in a nitrogen atmosphere so thick that sunlight barely reaches the surface as anything more than a dim orange glow. At that temperature, water is frozen as hard as granite, so methane and ethane take over the job water does on Earth. They evaporate, drift into clouds, and fall back down in a full weather cycle, complete with seasons, just built from entirely different chemistry. The result is a moon carved with rivers cutting channels through orange plains, and seas holding more liquid hydrocarbon than every oil reserve on Earth combined. Kraken Mare, Titan's largest sea, spreads across roughly 154,000 square miles, bigger than the Caspian Sea back home, with waves scientists suspect could rise several feet in Titan's methane storms. Subscribe now, because tomorrow's discovery is even stranger than this one. In January 2005, the Huygens probe fell through that orange haze and landed on Titan's surface, sending back photos of rounded pebbles scattered across a dry riverbed, shaped by the exact same erosion that smooths stones in an Earth stream. Scientists finally had proof the methane cycle wasn't just theory. Titan really does have rain, rivers, and shorelines, just running on fuel instead of water. Then came a stranger twist. The dunes stretching across Titan's equator aren't made of sand grains like the Sahara. They're built from frozen hydrocarbon particles that behave more like coffee grounds than sand, clumping together instead of blowing freely, because Titan's low gravity and thick air change how particles pile up entirely, stacking into ridges taller than a 10-story building. Comment below if you want to see a photo of that landscape, because it looks nothing like any desert on Earth. That strange chemistry matters because methane and ethane can link into complex molecules without any water at all, the kind of prebiotic building blocks scientists usually connect to the origin of life. Nobody knows yet whether anything could use that chemistry the way early Earth used water to get started. So the gentle gasoline rain falling on Titan tonight might be sitting on top of the answer. Hit the bell so you don't miss it when we find out.